Okay, so this one is the last topic from this first unit that we will complete in our today's lecture, right? So up to this, whatever methods that we have learned, all are used for the direct method, called the direct methods, right? So I just give you the brief summary about the topics that we have covered until now. Okay. So initially we have started with the introduction. So in introduction we have just completed the little bit things about the subject. What is the numerical method? Where it is used, right? Then how to check given matrix is a singular or non-singular. For that, what are we doing? We are just finding the determinant of the given matrix. If we get del is equal to 0, it means our matrix is equal to singular. And if we'll get multiple values, then we can say that given matrix is a non-singular, which was already given in your introduction PDF, right? Already uploaded onto the Moodle. Then after one matrix is given to you, then how to make the conversion from this square matrix to the triangular matrix, either upper or a lower, right? Then after, in this subject, two kind of methods are there. First one is the direct method, or second one is the, we can say, indirect method or the iterative method. Now, what's the basic difference between these two? So whenever we apply a direct method with the set of the linear equations, so we get the exact answers, right? How can we check it? So by substituting that value with the help of this back substitution, right? And by doing this, we got the answer. And with the help of that, we can say that whatever answer that we got for these unknown variables are the uh, appropriate, right? And for that, we have seen the different methods. The first one is the Gauss elimination method. In that, we have used the upper triangular matrix. Then two methods is the back forward elimination and back substitution, right? Then after, second method named is LU decomposition, right? And then after we go with this matrix inversion concept. In the matrix inversion, with the help of the LU decomposition, how to work with that we had completed. Then the second method that we have used for this matrix inversion called the Gauss-Jordan method. Now today's lecture will complete the last theory of this unit, which is the method named Gauss-Seidel method, right? Now for this method is used for the iterative, or we can say indirect method. Now why it is called this iterative or the indirect method? So over here, whatever values that we got for this unknown are not the exact solution, right? So for that, what are we doing? We are just performing the different iterations, and up to the two iterations, we get the same answers. We will follow the same steps. Okay. So first we'll start with this Gauss-Seidel methods working rule. So over here, same as the previous theories, your set of the linear equations are given to you, right? In this form. And what we have to do, we have to just solve these given equations for x, y, and z. These are the variables, right? Now, how to do this? So first of all, what we have to do in the first step, from each equation, we have to find out the largest coefficient of the x, largest coefficient of the y, and the largest coefficient of the z. Got it? And based on that, we have to write down these equations, right? It's the x, y, and z. Now suppose in these, we just assume this in these equations, out of these three equations, your a1 is the largest one. And with the help of this, we have made one equation for the values of the x, right? So x is equal to what? Simply d1 minus d1y minus c1z divided by a1. Same way, what we have to do? We have to find out the largest value of this y coefficient. And with the help of that, we have to prepare the second equation. And same way, with the help of this third values of the largest value of this c coefficient, we have prepared this third equation. Up to this, are you getting me? Just write down in chat box yes or no. What we have to do first of all, okay? Now in this second step, what we have to do? We have to go with this first approximation. Okay. Now in this first approximation, what we have to do, we have to initially consider what we want. We want to find out the values of the x. And for that, what we have to do, we have to assume this value of y and z is equal to 0. If values of y and z is not given, okay, then what we have to do, we have to assume by default is equal to 0. And by substituting y and z is equal to 0 in this equation, we will get the values of the x, okay, and this one is the my x1 value, and that will write down over here, okay. So now x value is with us. Now what we want, what are we doing? We are substituting this value of the x and z is equal to 0, and with the help of this we got the value of the y, okay, by doing this second step, okay. Now value of x and y is available with us. So what are we doing? We are just directly substituting these two value in our third equation, okay, and we got the value for z, which is equal to z1. So now three values are available with us after doing this first approximation or the iteration. Up to this, are you getting me? Clear? Okay. So now some values for x, y and z are available with us. Are you getting me? Just write down in chat box. Okay. So after doing this first iteration, what we have to do? We have to follow the same steps. Okay. And over here, what we have to do, if we want to find out this values of this x again, so over here, what we have to do, we have to substitute y is equal to y1 and z is equal to z1 into our first equation, and whatever value that we got for x, which is equal to x2. In second iteration, whatever value that we got, for that just write down the x2, y2 and z2, okay. Same way for the third iteration, write down the x3, y3 and z3. So you will not confused, right? So now after doing this first step, in the second iteration, we got the values of x is equal to x2. So what we have to do, we have to substitute this new value of x2 and z is equal to z1, z is equal to z1 into this equation number 2 and find out the new value of the y. Same way, new value of the z. Now how many times we have to repeat this step until our required solution that we got, okay. And how we got this? So sometimes after 2 iteration you got these similar values, or after in some of the examples you got these similar values after the 4 or 5th iterations, right? So that depends upon the complexity of the set of equations, okay. So these steps that we have to continuously follow till for a 1 or 2 steps we got the values of x, y and z as the same value, okay. And that's why it's called the iterative methods or the indirect methods. Fine. Now I'll show you one example so you will understand in easiest way. Okay. So this one is the one example for the Gauss-Seidel method. Okay. Over here, three set of equations are given. In first equation, 83x plus 11y minus 4z is equal to 95. 7x plus 52y plus 13z is equal to 104. And in third equation, 3x plus 8y plus 29z is equal to 71. So these three equations are given to us. Now what we have to do? We have to just find out the largest value of the x out of these three. So which one is the maximum? 83. So that I have marked as a circle with the help of the circle. Same way, in the second column, what we have to do? We have to just find out the value of the y as the largest. Okay, coefficient values. So 52 is the largest one. So that I have marked as a by circle. And same way, in the third column, 4, 13 and 29 is there. So out of these three, 29 is the largest one. So that I marked as a circle. Okay. Now, what we have to do? After that, we have to just make the equations for x, y and z. This one is our second step. Okay. So after doing this, in the first equation, we got the value of the x. So x is equal to 95 minus 11y plus 4z divided by 83. Same way, we have written this y and z equation. Okay, up to this, are you clear? Up to this, are you clear? In the first step, what you have to do, you have to find out the largest coefficient values for x, y, and z. Okay. Now, for the third step, what we have to do, we want to find out the values of this x, right? And for that, what are we doing? We are substituting this value of y and z is equal to 0. And by doing this, I can directly get this 95 by 83, and which is equal to 1.145. Okay. So now my new value of x is available with us. So just take this value for the second equation and z that we want as a 0. So for that, what are we doing? We are taking value of z is equal to 0. And by doing this, we got the value of the y. So now, in a second step, two values of x and y available with us. So what are we doing? We are substituting these values in our third equation. Okay? And by doing this, we got the value for this z, which is equal to 1.821. Okay? So this one is my first approximation. And by performing this first approximation, we got the value of x, y, and z. Now in second approximation, what we have to do? We have to take the values of x, y, and z. Okay. And try to find out the values of x1, y1, and z1. So in this second approximation, what we have to do? We have to take this value of y and z and repeat the same procedure. And by doing this, I got the value of x2. Okay, over here by default, by mistake, I have written x. You can write down this x1 or x2, whatever order that you are giving, right? Now this new value is available with us. So that value we have to consider in our second approximation. Just keep this thing in your mind. Whichever new values are available with us, after each step, that we have to consider for the next calculation step. Okay? Are you getting me? Just write down in chat box yes or no. Up to this, are you getting me? Everybody. Up to this, clear? Or any questions? Just write down in chat box yes or no. Everybody. Okay. So now my new value of x is available with us. That I'm substituting and value of this z. Okay. And I got this new y2 value is a 1.412. Now x and y, these two values are available with me. I'm substituting these two values in my third equation, right? And I got the new value of this z, which is equal to 1.958. Now these three new values are available with us after the second iteration. Now by using these, again we have to follow the same steps, and by doing that I got the value of x is equal to 1.051, y is equal to 1.344, and z is equal to 1.961. Now what I'm doing, I'm taking help of these values and again doing this fourth iteration, right? And by doing this, I got this same value over here. Okay, so whenever we'll got same values, so at that place we have to stop. And over here, after decimal, at least you can go with the 3 or 4 values, okay? And then only you will get these matching values. Are you clear? After this decimal, at least you have to take 3 to 4 places values, right? Then and there only you will get this accurate answer. So now just check it out. After this fourth iteration, my values of x and y are repeating, right? So over here, we have to stop. And these are our final values of x, y, and z. Okay? Are you clear up to this? So in this way, we have to find out the solution with the help of this iteration, with the help of this Gauss-Seidel method, right? Okay, now everybody, just do one thing. write down this set of the equations in your book and share your answers with me for x, y, and z, as well as the number of iterations that you have to perform. Are you getting me? Just write down in your chat box yes or no. So I will come to know you guys are getting me or not. Everybody, just write down in your chat box yes or no. And I assume that you guys have got these things, okay? So okay, just do one thing. Note down this example in your book and just tell me values of x, y, and z, and you got that value after how many iterations. Have you noted down this example? Just write down in chat box yes or no. Okay, just note down this example in your book. Okay, and just do the calculation. And for this subject, suppose your physical exam would be there, then you have to use this 82 ms calci only, right? No other specific calculator is allowed during the exam time. You have to just go with the 82 ms calculator. Okay, just note down this example and tell me you got the values of x, y, and z after how many iterations. Then I will share my answer with you. So you can cross check your answer, right? So everybody, just go through the each and every note of this unit. If you will find any questions, any doubt, any problem in any of the topics, just tell me. Okay. So over here, our first unit for this linear set of the equation would be completed. Now in the next lecture, we'll start with the second unit named the interpolation and the curve fitting. Okay. So in that first we'll understand about the what is the interpolation and what are the operations perform for this interpolation, and for that 4 methods are there that we'll study with the some set of the examples, right?